Hello and welcome. I'm Diego Salinas, Content Marketing Manager at Gatling, and I'm joined by Matt Piasta from InPost for a technical conversation about performance testing at scale. This is not a product demo, and it's not a marketing presentation. It's a real discussion about how a fast growing company like InPost approaches performance, reliability, and decision making in practice. InPost operates at a very large scale across multiple markets with demanding customer expectations and strong reliability targets. In that kind of environment, performance testing is not just about running scripts or generating load. It's about knowing what to test, how realistic your tests are, how to interpret the results, and who is responsible for acting on them. That is the core idea behind this session. Together, we'll talk about InPost performance testing journey, how their approach evolved, what changed with Gatling Enterprise Edition, and how their teams think about coverage, realism, analysis, ownership, and culture. We'll also get into concrete examples, lessons learned, and the role observability and AI now play in the process. Keep in mind, this is a pre recorded session, but Matt and I will be there for you live to answer any question you may have. So, let's get started.
Thank you for joining. My name is Matt, and I'm leading the site reliability chapter at InPost Group. Let me walk you through how we approach performance testing at InPost from very practical side. Brief look at the agenda. We'll start with a bit of about me and InPost, including some recent product launches like our AI assistant. We'll go through performance testing journey and how we design and execute tests, how we use AI, including Cloud Code, in our SRE workflows and performance testing, some real-world examples and stories, and I'll wrap up with some small advice for you around performance testing and application performance management. Feel free to drop questions in the chat as we go. Diego and I will pick them up in line or at the end. So, a bit about me. It's my 6th year at InPost, surviving between Black Fridays and Christmas as we deliver parcels to markets across Europe. I started as a web developer back in 2000 something, moved to quality assurance, then performance testing, and now my passion is site reliability engineering. My day-to-day stack includes Dynatrace, Grafana, PagerDuty, Terraform, Zabbix, Kubernetes, GitLab, stuff like this, and obviously Gatling as our main performance testing tool. As a team, we focus mostly on application performance engineering and obviously site reliability. We support development teams in onboarding to our observability stack, feeling also comfortable around it and embedding the performance testing as a part of definition of done. Most common issues that we face internally are the usual: some increase in response times, out of memory kills, garbage collection that needs tuning, some auto scaling issues, cache configurations with our CDN network, DB connection pools exhaustion, either by auto scaling or other issues like infrastructure bottlenecks. Let me describe a few of those in the next slides. For now, for those who don't know InPost, we are an e-commerce enabler that allows you to purchase goods through our mobile web app and using our huge out-of-home and door-to-door delivery network as in as few steps as possible. We originate from Poland, and vast majority of parcels in Poland are delivered next day, and we strive to have that same user experience across Europe. We've recently launched an AI assistant for a small group of testers that uses AI to initiate the purchasing process and guides you through the experience in a fast and friendly way. It's still in testing phase after rigorous performance validation, but in my humble opinion, it's a game changer in the way users will approach buying stuff online. One second, I need to check something in our presentation. Okay, we're back. So why do we care about performance? It's it's not a phrase in our company. It's the core value. It's not something we do because we have to. The speed, the reliability of our services literally sets the market standard for parcel delivery in Poland and increasingly across Europe. There are three main drivers for this. First one, our responsiveness defines what customer expect. Whether the parcel locker with your goods opens in a blink of an eye, the parcel tracking push notification comes in milliseconds instead of seconds to your phone after our courier places it in a parcel machine. That becomes the baseline expectation for entire industry. Next thing is we have a very rigorous product SLA, either 3 or 4 nines, depending on the product. But that means that performance validation is not optional. It's mandatory before every major product launch to avoid error rate increase and response time degradation. Third, the last but not the least, customer satisfaction. Our App Store and Google Play ratings directly depend on how fast and how smooth the experience is. A slow checkout or a laggy tracking system or a slow parcel machine opening would mean lower ratings, and lower ratings mean fewer users. What you see here is a screenshot from our service dependency graph from our monitoring system. That looks like a huge galaxy, basically, and I hope this helps you understand why performance is important to us. We have to keep even the smallest microservices like label generators performing extremely fast so that it doesn't harm the overall user experience. Next slide. Yeah, so now you know our motivation, so let me walk you through the transformation journey. And for that, let me take you back a bit. Before we went with centralized platform like Gatling Enterprise, the whole performance testing exercise was a one-man job, or actually a one small team job, and it was my job and my team. I owned most of the tests, and I ran all of them through a multiple load generators that were kept on premise. And in that time, I started transferring my knowledge to more and more quality assurance professionals and developers, and that worked fine when we were smaller. But now, when InPost started acquiring companies and growing rapidly across Europe, and also internally as a company that also delivers software, that no longer scales. IT organization expansion means that teams were waiting in queue either for my team availability or load generators availability or test environments. So we're also limited by our on-premise infrastructure, and only selected products were being able to test their performance on some meaningful load patterns. So the shift to cloud, it's a step that our company made last year. Obviously allowed us for more dynamic environments, provisioning, more load generators, and more flexibility with all of the resources overall. But the SRE bottleneck was kind of still in place, so we decided to give it all to developers. And this was possible by having centralized load testing platform and a centralized performance testing repository. And the shift from open source to Gatling Enterprise actually changed everything and changed how we approach performance testing right now. We now have a very well documented performance testing examples, real life code, centralized repository, monitoring, and all unified in concise experience across the company, regardless of the country in Europe. And most importantly, SRE team now has the visibility into development team's effort around performance testing. We have central logging. We are hooked up to Gatling MCP with performance test reports. Actually, enabling Gatling MCP enabled all of the integration with other our MCP servers, and now Leveraging AI analysis capabilities, we can now correlate performance testing runs with metrics in real time and compare it to historical values. Also, developers actually want to use this. It's like fire and forget now, and we simplified it as much as we could, driven by standards like application performance targets described in our internal Confluence, that developers should strive for during performance testing. Today, over half of the development teams is already onboarded to Gatling Enterprise, and we aim to close this gap in the coming months. So our IT is quite big, and in the past year, since we subscribed to Gatling Enterprise, we've onboarded over half of them to be a self-service for performance testing, along with the observability stack. We do infrastructure as code, and all of the alerting and monitoring configuration is just a YAML file for development teams. And we want to go in the same way with Gatling Enterprise. The teams develop their testing code. The submission to Gatling Enterprise is automatic, and then they can run it from the platform or from their CI within the developer pipeline. The wheels are rolling. Teams onboard themselves, following our guides. So right now it's available very quick without reinventing the wheel. They can look into the repository, see what other teams were testing. Do not duplicate logic like creating fake users for testing or manifesting partials. So the process right now looks like that. The developer teams clone the repository, contribute their tests, run it in a small virtual user batch from their own development machines, then push it to our repository. There is a merge request review, then it's being pushed to Gatling Cloud as a package and can be run from there. And having a set of application performance targets mentioned earlier guides the developer teams to setting appropriate goals, Gatling assertions, and in future service level objectives on monitoring systems. That can be validated before going to production on a simulation level. And this is an example of actually an extract from our documentation about performance testing targets. This is a short guide for development teams with multiple examples and links to other, for example, databases that are in production. For this example, I believe is from PostgreSQL. And we measure that with Dynatrace. As you can see, we have a pretty rigorous target of 1 millisecond response time on average from the database that we actually meet. And this is the time when measured the request round trip from application backend to the database. Okay, so before I head on to how we design tests, let me grab a quick sip of water. So when it comes to deciding what to test, we have two main approaches. First, follow the traffic or follow the money. We analyze something called critical user journeys using Dynatrace. We try to identify the top 5 user paths by volume and use AI to generate critical user journeys as a request response flow directly in our centralized performance testing repository. And Gatling MCP is a huge help, bundled with skills and agents that we have in Code, and obviously our documentation. I say we, but it's not only the SRE job. Primarily, development teams owns the test repository. We are merely the reviewers and auditors. And once we have this CUJs, we combine it with paths identified by business owners, because sometimes the most important path, it's not going to be the highest traffic, but the one that matters most to the business. The next second thing is AI assisted test creation, and having the huge data lake like Dynatrace monitoring data, we hook through MCP to Dynatrace, hook also to Gatling, and with appropriate cloud code agents and skills, we can derive request response patterns, also using logs in Elasticsearch, and that help us build the test scripts. That said, AI helps, but still human has to be in control in the end. So every merge request has to be reviewed by SRE team or a principal software development engineer. And our definition of when is enough is when we have at least 3, maximum 5 user paths from production traffic analysis, plus any paths that business has identified as crucial. Okay, so this is how we have designed our testing structure. There is something called performance testing agent. It's kind of looks like we as SRE made our digital clones and in form of agents and skills and push it to our Git repository, compressing the SRE knowledge in Markdown files. It's not perfect yet, but we've been tuning it for a few months now, and it covers a lot of cases and delivers stunning results with tests designed based on real user data, like we have from real user monitoring. Each skill we write has a clear README, needs to be cloned to local user directory, and once loads is a skill. It reacts to certain commands like help me design a performance test for this and that based on data from this service. You paste a link, and then magic happens, and I will try to show you that magic in the coming slides. So I cannot share too much about how we design the flows, but showing here just a glimpse of how we do it. What you see here is the business flow mapping done in Dynatrace using unique correlation ID that can be a parcel number, user phone number, email, or whatever else you might think of. That is passed through different headers or request body or part of a JSON or part of a CSV file, whatever comes to your mind. It can also be a unique identifier set by the development team, especially for purpose of this exercise, or a trace ID to be followed across logs. And linking that unique identifiers through various services allows to build the flow that is then consumed by AI or read by human to build the test. And here's an example of how we work with Claude. Depending on the task, we use more complex or faster models. This is an example of using the most expensive model, and that needs to work with large context of data. Using this skill may not be the fastest one, but for this particular exercise, it produces the best results from what I managed to test so far. Here we have the example of analysis done by AI on production data. You can see it got the response time percentiles, error rates, and common traffic patterns. Then it generated load profile based on this, so we can simulate traffic as close to production behavior as possible. Try to be around 80% to have some margin. But when we are doing peak traffic preparations, we usually get these recommendations and try to double that, just to be sure that we do not hit any bottlenecks if a sudden spike happens. And with AI hooked to our central repository and to the data pattern, the generated load profile based on all of this data can be a ramp, stair, heavy side, or any other function. Whatever you think or whatever AI will think is closer to resemble the production traffic. But we don't always do tests like that. Sometimes we just want to test the limits. So we use a simple ramp with sustained flat load to see what happens. And the load patterns that we usually do in the beginning are very simple and quick, from 5 to 15 minutes. Then we try to do usually a soak test that should last at least 8 hours and the longest test that we've run was 7 days. And I have a small mention about it in the next slides. Back to the design. In this demo example, there is a complete session from Claude that actually you can see it took nearly an hour, 52 minutes. It is quite lengthy, but I was reading the output thoroughly, reviewing the files, and managed to get a coffee in the meantime. So it's not a bad result for a $6 token usage. Definitely it would take me longer to deep dive through this data and code this manually. But obviously a simple demo, and some more complex scenarios may need to be crafted by hand. But AI does pretty good jump start and project structure draft, so you don't have to start from scratch. And most importantly, follows the code guidelines that we already set in the repository, in the README, and it always reads the README and does not reinvent the wheel. So if there's already a fake user generated that I mentioned a few minutes ago, or an email validator or something like this, it will probably use it or try to enrich it with necessary fields to meet the current test requirements. Okay, enough about test design. I hope I did not bore you. So we try to delegate as much as we can. As a SRE team, with the best teams, we're just needed once or twice during the process, and then it's an actual self-service. There are some exceptions, obviously. For example, last week we've had a situation where the test results were failing prematurely, and SRE team help was needed. So we made some fun out of it and actually run a race, run Claude workload on the data at the same time as one of the SREs looked at it manually. And fortunately, this time human won, but the AI report was very neat and also spot on and correct. So we used it as a test report and a baseline for the action items and tasks that we had to create in Jira for another teams to fix it. So let's actually see one of these examples on how we analyze the test results with SRE team. You have some basic performance targets that we have set towards our microservices, database queries, and web applications. So usually with these performance targets that everybody knows, they're in place. The development team designs the tests, run it, and calls SRE for help if something is not clear or they're unsure why something is happening. The example at the bottom actually comes from the fact that the development team didn't use connection pooling in Gatling, but even after they fixed that issue with their tests, there was still some closed channel exception, SSL handshakes, connect timeouts, and whatever else you can see in the screen. So all of that, all in one. And the SRE team was asked to help look at the deployment config, Kubernetes ingress, Cloudflare, or etc. And this particular test was actually run in production. So also we were looking at our web application firewall that could have been involved. So what happened here? You can actually see that after a few minutes of sustained load, there is a classic response time degradation and a wee bit of very weird behavior of requests per second, while at the same time, the application monitoring from Dynatrace says that actually app is okay. And it doesn't actually reflect the response time shown in the load generator at all. So what we are doing, we go to AI in Gatling built-in, try to get as much summary as we can from it. And the built-in analysis in Gatling Enterprise is pretty neat. It produces the great overview, but it lacks the context from other data sources. So we copied that output into our internal SRE agent, gave a link to the test, checked that Gatling MCP is hooked, so it can also look into other test results, and gave it a link to the centralized test repository, and using performance testing skill, asked it to help diagnose the issue. This is what happened. When with an agent that performs analysis based on complete set of data sources, including our cloud environment, Kubernetes logs, monitoring system, performance testing environment, we are able to get a quite correct recommendations pretty fast. What you can see here is actually an extract from Markdown file with specific recommendations. Even if they would not be 100% correct, they could help the development team or anyone who will be looking at this code. It can help deep dive into a specific place that they might have forgotten to check, and get some detailed info about test run from sources other than the load generator itself, which is very important. This particular test run turned out to be correctly analyzed by Claude, actually. Then this suggested Nginx deployment settings allowed for unblocking the ingress bottleneck. So, point for AI. Okay. So, I spoke briefly about load estimation, and obviously it's much easier when the application is released and monitored already. We have data from Dynatrace, and when we expect some bigger traffic, we just go ahead and simulate it on ephemeral, short-living environment, or a downscaled environment to the relevant sample. But the load estimation mostly comes from the data that we already have in monitoring system. But that's not all. To prepare for peak logistics season that is starting before Black Friday and lasts until Christmas, we have to start actually around April. Get forecasts from business intelligence, from data, from AI teams, from our branches, central sorters, etc., and evaluate all of that predictions. Without AI models, it would be extremely hard to do. So we've been using AI before it was fancy. And before starting the actual performance test, SRE team sits down with development teams that own specific app that is yet to experience the biggest traffic increase, and we analyze the options together. Maybe something needs a rebuild. Maybe we can change the hosting mechanism. Maybe we can split the application into smaller pieces. Sometimes even without performance testing, we are able to tell that this won't fly and we have to do something before the peak, and run the performance test on the newly designed solution to confirm that it is able to sustain the same load, the bigger load, bigger expected load than the previous one. And all of this database estimation is also possible thanks to monitoring, as I mentioned multiple times already, but also because we have the same monitoring system in non-production and production environments. This is very important because if systems are monitored the same way, you get very concise results. And we are able to pull, for example, 30-day response time data from the test environment that was running some functional tests in Selenium or Playwright constantly every day. And based on that, we can see that maybe, hey, there's a memory leak or something, and we apply the same principle to production. When we set any service level objective, we pull the data either from 1 year, from 1 quarter, or 30-day response time data. That later leads to setting up reliable Gatling assertions during performance tests that actually are realistic, possible to meet. And obviously, the development team should try for those assertions to be as close to application performance targets as possible. And obviously here, AI, again, is a huge help. But what about apps that haven't seen the prod yet and are not running this Selenium Playwright or any traffic generators? Well, it's slightly more difficult as we never know what the user engagement will be. We have very limited set of data, but we already have hundreds of applications. So we can base the estimations on our experience and similar applications that we have already deployed in production. and then just double that estimations to be safe. But to be absolutely serious, whatever estimations we do, we always try to confirm and prove that the application can scale. Reach the limit of the first initial estimated setup, and then add some resources, pods, increase database size, whatever, introduce some bloat into database, test again to confirm if the application scales linearly or maybe there's some new bottleneck to be approached. You know that there's never enough testing, but we have to have some limits, and this is it. Okay, so what do we do when someone actually finds an performance issue? And performance issue can surface from various sources: a call center user report, infrastructure team, database team. Everyone is entitled to file a request to improve application performance, and the development teams actually own it. That's clear and unnegotiable. If they have difficulties reproducing or debugging the issue, SRE team is there to help and solves any disputes, but tries to bring the strong mandate to fix the performance issue before next mini peak occurs, and we have those mini peak seasons before any longer bank holiday. So usually when we define some serious performance issue, it should be fixed within 2 weeks or sooner. Having a set of platforms with live monitoring data is obviously huge help here, but having a possibility to run the performance test by anybody is even better. We've seen, thanks to Gatling Enterprise Platform, we've seen performance tests being triggered by not only the development teams, but actually by supporting teams like network guys or incident management teams or infrastructure guys or DevOps. So to suit their needs, perform the chaos engineering tests what happens when suddenly somebody changes DNS records, stuff like this. So not only this platform is not only used by developers, but it actually starts to grow as a nice tool for other employees at InPost. Obviously, with virtually unlimited load generator possibilities, we can still sometimes hit the issue of a noisy neighbor on one of the test environments. So we have a good practice when multiple teams work on the same environment. Once the test is designed and proved, we usually recommend to run it overnight just to double check the results and exclude noisy neighbor disruptions. Okay, so some real world examples. I have a few of those. Something that we caught early, thanks to logistics forecast. 2 years back, we received the forecast was a little bit late, but it was an information that we are to expect a significant increase in parcel volume through our logistic network. And after running performance tests that we prepared beforehand, that we can run every year during peak preparation, we realized that it's actually too late. There's too little time to fix it because it would need to cloud migration of one of our largest databases, and we weren't ready for that yet. So we decided to disable non-essential features. For example, adverts on parcel lockers in the parcel handling application. So thanks to that, we lowered the traffic to the main database and actually handle the peak pretty neatly. Decision was made before the events, not during it, so it decreased the possibility of failure by some percentage. And you have a clear value of testing and forecasting right here. What slipped through though, as in many companies that I've seen, the third-party dependency. Despite all of our test efforts, one of our major payment provider in Poland experienced performance issues that we couldn't simulate. We had to temporarily disable this payment option support during their outages. We always ask third-party providers to expose a perf test environment or even a boosted sandbox or any test environment that we can scale a bit so that we can run a bigger simulation, but that's not always possible. So lesson learned here, with third-party apps or services, it's always good to have a backup plan. Most complex solution, most complex test suite, I think I mentioned that already. We have run 7 days logistics simulation. Even though we strive to get parcels delivered the next day, the week always has 7 days. Sometimes our couriers work over the weekends. And the goal here was to simulate full parcel flow from creating a label, or actually from manifesting the parcels through one of our systems, to actually picking it up by the customer, but not the life cycle of a single day or 2 days actually when the parcel is picked up and delivered, but the simulation of the whole week of work of the whole logistic network. And this validated throughput across the complete logistics chain. It's probably the most unusual test I've ever run. There was a lot of dependencies between the specific simulations. Uh, right then, I ran it still on Jenkins. We didn't have Gatling Enterprise yet. We were using Gatling open source, and the single simulations were saving the data somewhere to CSV files, and these CSV files were read on the fly by another simulations as feeders, and these were looped over 7-day window. And actually, it allowed us to reach a decision to completely redesign the software architecture that we had back in the day, and proved that we had to decouple a few monoliths and in one place create our own logistic system from scratch, which later became one of the biggest systems like this in Europe. And the 7-day simulation lived for over 2 years after that as a benchmark before release. And even to this day, we actually use the same approach to deliver performance integration tests that validate if our logistic network is still capable of handling the sustained load. Last example of infrastructure bottleneck that actually sped up cloud migration of one of the apps a little bit. So performance testing on our self-hosted infrastructure confirmed that we needed to scale beyond what on-premise could handle. This specific example was that on self-hosted Postgres database was hitting its limits. It cannot sustainably handle the traffic pattern. It must periodically run vacuum and analyze to recalculate statistics, which introduces huge performance drops under load, especially for update statements. And with databases like that, we have 24/7 loads, and this kind of databases, for example, serve authentication tokens. So it started to be necessary to run these recalculations every hour. DB team, database team proved that even with full hardware isolation, the new Postgres instance would not be sufficient to stabilize performance in the long term. And during performance test and later in production, the DB would have a lot of logs, and processes would wait on the same tuples. And we've seen that using the monitoring tool called DB Marlin that we have for databases. The application can obviously recover very easy after this every hour after a vacuum analyzer are run, but it's unpleasant to work with hourly response time degradation. So the DBA team made a decision that actually Cloud SQL can simply better leverage caching, reducing the maintenance effort operations on live traffic. So that's a wrap. I'm gonna be Mr. Obvious here, but having the same monitoring system in pre-prod and prod changes things a lot, and catching some performance issues can actually be caught a lot earlier with simplest GET requests, and with current AI possibilities out there. Building and running performance tests is super easy. So I advise you to invest in the right tools. Having data just from load generator is not enough. To get the full picture, the tester or developer needs to analyze monitoring data, infrastructure state, state of the network, and having the right AI tools actually helps you not to drown in these huge data lakes. And for some workloads, I also recommend running a suite of functional tests like Playwright or Selenium with video recording and spend some time reviewing it along with time measurement, how long did it take, so that tester can visually assess the performance degradation, if any, in application UI. And the third one, automate, automate, and again, automate. The era of manual testing seems to be over, and I sincerely advise you to get acquainted with AI to learn to use it efficiently while it's still cheap. And by efficiently, I mean try to work with cheaper models so that when the expensive models become really expensive, you will know what to do. Even the cheapest models like Claude Haiku, when fed with right data, can help you design the test scenario paths that you might have missed. Thank you. That's it from my side. Thank you all for listening and spending this time with us. Happy to take any questions, drop them in the chat, and you can reach me on LinkedIn if you want to continue the conversation. Thank you.
Matt, thank you for joining us today, and thanks to everyone who watched. This conversation showed something important. Performance testing only becomes truly valuable when teams can turn results into signals they trust and act on. That means better coverage, more realistic tests, stronger interpretation, and clear ownership. And that's exactly what made InPost's experience so interesting to hear. We hope this session gave you useful ideas for your own approach to performance testing at scale. Thanks, and see you again next time.